Hello class, welcome back. Thanks for tuning in. Thanks for being here. You know, obviously these last couple weeks have been kind of crazy, but again, I appreciate all the work that you guys are putting in. I know some of you are really diligent about checking the videos and whatnot. So thank you for that. But again, this is a distant second place. Priorities right now have to be your health, safety, your family's safety, your family's health. So take care of each other. It's important right now. But again, let's just jump right into it. Let's talk about the topics today. If you're still sticking around, and we'll kind of go through it. So here's the topic. So on our iPad here, you can definitely see we're in week 6, part 1, and we're talking about proper scientific notation. Now, scientific notation is a way of basically taking a really kind of any size number, preferably they're bigger, really small numbers, and making them so that they can fit on your calculator screen. Because I know certain calculators can only fit, like 8 characters. So this was a shorthand for making the numbers smaller so you can actually do some math with them. Now we're going to just touch on the basics in this one. The next lesson we're going to do later in the week will be, focus on, what can we do with this stuff. Now I know in the Google form that I'm going to be sending out today, it's going to be based on, some real life problems that are, kind of based on this topic. So I'm trying to show you kind of what you can do with it, but it's not difficult. You just have to rearrange numbers and write them into different forms. So the classifications of numbers, which you can see in front of you, are natural numbers. So it's like 1 and up. So 1, 2, 3, no decimals, nothing like that, just nice clean numbers. Whole numbers are 0, 1, 2, 3, nice clean numbers. Then there's integers, which are like negative numbers, so -3, -2, -1, 0, 1, 2, 3, again, no decimals. Then we get into rational numbers, which are kind of the ones we're kind of focused on today, which are decimals, or anything that can be written as a fraction. That's the proper definition of it. And then irrational numbers are anything that cannot be written as a fraction. So the steps we're doing today are for really any of these types, but it's, if you have a really big number and you want to make it smaller looking so it can fit on your calculator screen. So we're going to be using powers of 10. That's one of our topics, as you can see here, and then changing the decimal place. That's really it. So it's pretty easy. So let's jump right in here and we'll kind of look at the first problem here. I got about 5 problems picked out. So the example you're seeing in front of you is 0.0012. Now this is a very small number. It's 5 decimal places. So the idea is that you can make this number different, smaller, and so that it can be easily typed on your screen. Now I know a lot of you just type in 0.0012, but maybe a calculator won't display it that way. It'll try to display it in the shortest hand possible so that it's easy to look at. Well, that could be confusing, and you want to see this number because maybe you're doing some experiment and this is the number coming out, but your calculator's giving you a different form, and that's probably scientific notation. So let's just talk about what scientific notation is. It's taking this decimal place and moving it behind the first number on the left side, ignoring all zeros. It's going for the first number that you see. So I'm going to move that decimal behind the first number, and you chop off all the zeros. Then what you do is you look and you count how many spaces did I actually move the decimal. I moved it 4 spaces so that it's behind the 1. It's in between the 1 and the 2. So what you do is you use a power of 10. Because what tens do is they move decimal places. So what I'm going to do is I'm going to put a -4 on this power of 10 that is in the exponents, in the power. And what that does is it takes this decimal and moves it 4 spots from where it originally began. This, what you see here, is proper scientific notation. Proper means you have it behind the first number on the left side. And negative means that basically what I always think of as a negative power, it's basically telling me that my original number, if I switch colors here, my original number was less than $1. That's basically what it's telling me. So it's 0.0012, so it's the decimal side. If it was a positive 4, it'd be on the larger side, so it'd be larger than $1 in theory. Depends on how many spaces you moved it, really. But this is scientific notation. That's seriously it. That's what I want you to get kind of focused on. So let's go into our next one. So just jumping into different problems here. So let's go back to my red color here. All right, so we have a number like 700. Again, I'm sticking with small numbers right now so we get the idea. So right now on 700, the decimal's in the back. All regular, this is a natural number. The decimal's in the very back. They just don't have to print it. So what I'm going to do is I'm going to move it behind the first number on the left side. So the first number on the left side is the 7. That's an actual whole number there. So I'm going to put 7.0. Now what I do is I put a power 10 behind it, and I count how many spaces did I move it. I moved it 2 spaces, right? I jumped 2 spots. So what I do is I put a power of 2 on that 10. And it's a positive power of 2 because this number, my original digit, was bigger than $1. So I'm moving it to the, I guess, the left side, not the right side. That's how I know it. Positive powers. This is my answer. That's what I'm looking for. That's scientific notation. Again, you're thinking, I could just write 700. It's easy. I can just type that in. Yeah, the purpose of what we use scientific notation for are for really big numbers. I've been showing you really kind of just basic numbers, small numbers, so we can get used to like how many spaces so you don't get lost in the counting. But let's jump into another one. So these are the same number. They're interchangeable on a calculator. Now the calculator, some people have like a power 10 button. Looks like this on their calculator screen. I know some Casios have that. You just type in that. It shows up on the screen. You type in your power and you're good to go. Some people have a little EE button. Same thing, you hit the EE button, it's going to wait for your power, and it's basically the EE stands for the power of 10, and that's what you're looking for. That's really the only two types we have. All right, so let's go to the next problem. So what we have here is 3.2. 3.2 is already written in proper scientific notation. The decimal is behind the first number on the left side. So 3.2, right? I don't even need to move it. So this is the same thing. Since I don't need to move it, it's a power of 0. That's the idea. I didn't have to move the decimal right or left, so it's just a power of 0. You don't need to write it like that. Now, the idea is that I keep saying proper scientific notation. There's two types of scientific notation. There's proper, where it's always behind the first number on the left side, or you can move it anywhere you want. You can move the decimal anywhere. So I could, in fact, move my decimal here and write this number like this. I could. I wouldn't want to, but I could. And then I just have to put a power of 10. That's all I do. And I just count how many spots did I move it. Well, I moved it this direction. I moved it to the, I guess, the left. So this will be a positive power because I'm moving it this direction. And I just count how many spaces did I move it. Well, I moved it. It was right here originally. And I moved it 1, 2, 3, 4. So I'm going to put a 4 in my power. And what you're seeing right here is the same thing as my original number, which is the same thing as this. They're just written in different forms. One's in proper scientific notation, one's in just regular scientific notation. So proper means it's behind the first number. Now let's actually go to a real problem. Something that's, a big number that you do have to move the decimal because the number is too big. You can't type it in most calculators. The newer scientific ones you can. So let's go to a bigger number here. Actually not this one. Let's go to a different one. Yeah, okay. Here's a bigger number. So we have, what is this? 4 billion? 4,900,000? So the decimal in the back, this is a natural number. It's, it's not a decimal at all. The decimal's in the far right side. I'm going to move the decimal. So I'm going to move it behind the first number on the left side, so 4.9. I'm going to move it all the way over. So this is called proper scientific notation. I'm going to put a power of 10. And since I'm moving it to the left, I'm going to use a positive power. And I just count how many spaces I move it. Well, I can just jump by 3s, right? So 3, 6, 9. I moved it 9 spots to get it to there. So I'm going to put a positive 9 in the power of 10. And that's the same number. This is the same digit on my calculator as the number that you see there, the 4,900,000 number. Now, why are we doing this? Again, it's to make numbers smaller so we can actually do basic operations with them. Some calculators choose to display all numbers in scientific notation. The reason why, it's easier, less typing than obviously the 9 billion. Some people get lost in the zeros, but it's just an easier way of doing math. It makes numbers smaller. Like 4.9 is a smaller number than 4 billion, and if I had to add numbers or multiply numbers together, it's better to get rid of all the zeros. That's something we're going to look at later this week. But again, let's do one more, the problem that I skipped earlier. Let's see, the problem I skipped here, so 0.0055, I'm going to move the decimal, so I'm going to do proper scientific notation. I'm going to move it behind the first number on the left side. So the first number I saw was 5, so I'm going to put the decimal here, 5.5. Now, since I moved my decimal to the right side, I have to use negative powers. And I moved it, 3 spots? So I put a power of 3 on it. And that is my answer. That's the proper scientific notation for it. That's what we're doing in the Google form. So if you look at all the problems, they're going to give you some words and some real story-based application for it. But then they just want you to write in scientific notation, and this is it. Now again, how you could type this: you could use the little ×10 button if you have that on like a Casio. You could use the little EE button on like a Texas Instrument. Some calculators actually have. They actually have a little caret key. So you could put things in powers and type in, the -3 like that on the 10. Some calculators actually have an x to the y key, so you can put 10 to the -3rd power, or a y to the x key, where it's in like little power. So these are all the different buttons you could use to get to the same result. That's the idea. I know that I went through that really quick, but this topic is bigger than what I'm showing you. I'm just showing you the basics right now so that we can use it for a bigger application later. So this will become apparent later in the week and maybe in the next coming weeks. But again, thank you for all those who are actively participating in this. I know it's not it's not easy. I know it's kind of a weird time right now for us. But again, take care of each other, take care of your health, and stay safe. But thanks for tuning in. See you guys later.